Hey guys, welcome back. I hope you had a very restful spring break and you enjoyed your Easter. We are starting chapter 11 and it is all about three-dimensional shapes. So we're looking at all sorts of different solid figures from pyramids to cones to cylinders. So we'll be talking about those. Today is kind of an introduction day. It's just starting to talk about some of the terms that we're going to see. So the first term is our overarching term. It's a polyhedron. A polyhedron is a 3D figure whose surfaces are all polygons. So remember, to be a polygon, it has to have straight sides and be closed. So what we're looking at today is first defining the parts of a polyhedron. The first part we're going to look at is what's called the faces. The faces are the flat surfaces on the shape. So for instance, right here, if I looked at this flat surface, that is what we call a face. Edges are next. Edges are the segments where two faces meet. So we're looking at this piece right here. It's really the segment in the picture. So that piece right there is what we're calling the edge. And then the last piece we're going to look at is what's called the vertices. The vertices are the point where the edges come together. So we're looking at like these corners here. So think of it as corner. Those are what we call the vertices, or singular for vertex. So that there is a vertex. Okay? So we're going to start by counting the different number of faces, edges, and vertices in each of the polyhedrons in the next two examples. What I need you to do, the easiest way to do this, is to be organized and count them in groups. So we're going to start with the faces. So if I look at the picture, there are definitely, if I group these together, two triangles that are faces. Those are the flat surfaces. And then if you think about the other shape in the picture is the rectangles, how many rectangles there would need to be to match each side of the triangle? There'd be 3 rectangles. So we have 2 triangles and 3 rectangles, which means in total there are 5 faces. But really group those together so that you can count those accurately, especially because you have to think 3D here. And it's kind of hard to do that. If we were in class, I would have you guys looking at a physical shape so we could do this more physically, but since we're not, I can't really do that. So you have to think 3-dimensionally. You've really got to be organized when you're counting. All right, let's do edges next. Edges, remember, are the segments. They're these pieces that connect the faces together. So there's 3 on the triangle on the top, and there'd be 3 on the triangle on the bottom. So again, I'm grouping these, and then there are 3 connecting the 2 triangles together. So that's 3 plus 3 plus 3, which gives me a total of 9 edges. And then the last thing we're looking at is vertices. Those are the corners. Again, I'm going to try to keep the ones that are on the same face together. So do these in groups. There's 3 corners on the top triangle, and there's 3 corners on the bottom triangle, so that's just 3 plus 3, which is 6. Let's try another one. So in this one, we're trying to count faces. Again, faces are the flat surfaces, so I definitely have this, I have this hexagon on the bottom. So there's 1 hexagon, but there are then the triangles coming down, and you can't see all of them in this particular picture, so you have to use your imagination a little bit. You have to think about how many triangles would come down to connect to each side of the hexagon. There would be 6 triangles total. So since that's 1 plus 6, there are 7 faces in this. Then we're going to look at the edges. The edges, again, are the lines, the segments in the picture. So we're going to do it in groups. I'm going to count the 6 on the hexagon on the bottom that has 6 edges itself. And then you need to think about coming down. There would be 1, 2, 3, 4, and then there would be 2 more on that back side. There would be 6 coming down to connect to all 6 sides. So that's going to be 6 plus 6 coming down from the top, which means there are 12 edges. And then the last thing we're looking at is vertices. I'm going to group those together as well. There are for sure 6 corners on the bottom shape, but then there is also one corner up here on that top of the shape, so that is 6 plus 1, which tells me there's 7 vertices. Alright, now the next part is what's called Euler's theorem. Euler is a famous mathematician. He came up with the concept that if you look at all of these polyhedrons, there's actually a pattern to it, that if you add the faces plus the vertices, that's equal to the edges plus 2. So if we just look at the last one we just did, just to check out his formula here, and this is something you can do after you've answered the question, after you've filled in all 3 numbers, check them and see if this works. This says the faces is 7 plus the vertices is 7, has to equal the edges, 12 plus 2. You notice we get 14 equals 14. So this will work for every polyhedron. So that's something nice for these first 2 examples we did that you could use after you filled in all your numbers. Use it to check to see if you counted correctly, to see if they match up. Alright, so now we're going to use that to find the missing number in this next example. So they're telling us the number of edges and the number of vertices, but we don't know the number of faces. Super easy, you just got to plug into the formula. This is going to be, we're going to keep it f because we don't know. F plus 9 has to equal 15 plus 2. And then you're just solving. F plus 9 equals 17, and if I subtract, I get f is equal to 8. So this one would have 8 faces. Alright, looking at number 7, we're just going to fill into the formula again. This time we know the faces. So it's 8 plus vertices is 6. Has to equal edges, which we don't know, e plus 2. And then we're going to solve this. That's 14 equals e plus 2. And if I subtract, that tells me e has to equal 12. So there would be 12 edges. And then the last one, faces, plus we don't know vertices this time. V equals edges plus 2. That's 20 plus v equals 32. And then if I subtract, that's going to tell me v equals 12. Okay, so those ones should be relatively easy. You're just practicing using that formula. The last thing we're looking at is what's called a cross-section. A cross-section is a plane that intersects a solid figure. These planes can come in flat, they can come in at an angle. The cross-section part, though, here's the important thing. You need to figure out the flat figure that would be stamped on the plane. If we cut it, and if you imagine slicing it open and opening it up, you want to see what flat shape would be on that opening if you cut it apart. So if you look at the first example, they were doing the cross-section of what we call a cylinder. And this shape, that is what would get stamped on that plane. So that cross-section is a circle. Everything you do here should be a flat shape as an answer. So it's not going to be like pyramid or cone or anything like that. We want to know what flat shape would be there. And then the next one's a pyramid. We're cutting through, if you imagine there's a plane here, you can't see the whole thing, but there's a plane here cutting through, and we want to know what shape this is that gets stamped on there. Now you do have to think of this, it looks tilted right now, but we're looking at it in 3D, so if we untilted it, that would actually end up being not a parallelogram, but it would have right angles. So this would be a rectangle. So now I'm going to show you guys a video just to help you see a little bit more visually, because this is so visual, what cross-sections really are. So what we're looking at here is the pyramid. Watch if I do the cross-section horizontally here. If I do the cross-section horizontally, you can kind of see that it pops up here, that shape would be a pentagon. It's the same as the base. But just to show you what a cross-section really is, the cool thing that this does is it pulls it apart. So now if you look at it, you can see what we're looking for is that flat shape, that if you were to cut it apart, what shape would be there, either on the top of that bottom piece or the bottom of the top piece, but that's the shape that we want. So now what if I cut it the other way? Let me see if I can get it to cooperate. If I go vertically here. I want you over there. So if we went vertically instead, and I pull it apart, you see that if I cut it straight down from the top, that ends up being a triangle instead. So again, it's just that flat section that we're looking for. Let's look at one more type of shape. What do I want? We'll do this guy. So this one, if I cut it straight down the middle, think of this as a wedge of cheese, and I'm cutting it straight down the middle. Oops. It's not going where I want. I want you over here. There we go. So now, if I cut that slice of cheese straight down the middle and I pulled it apart, that would be a triangle. What if I cut it from the triangle side, though? If I cut it from here, and cut it that way, cutting from triangle to triangle is going to create a cross section that is a rectangle. So again, you got to think of this. Sometimes it looks kind of slanted-y and weird, but you got to think about what the shape would be if we looked at it from the top. From the top, it would have right angles, so that would be a rectangle. So again, you're just giving me the name of the flat surface that if we were to cut it and look at what shape is on that cut part, think of it as a block of cheese or a cake or something like that, what shape that would be. So hopefully this visual demonstration helped you think through it a little bit. So here's a couple of examples for us to practice with the cross section. So the first one is what's called a cone. Think of that as like a party hat. If you were to take that and slice it straight down the middle and open it up, we need to think about what shape would end up being copied onto the cone. So we're looking for that flat shape that would copy onto the cone. This one would be a triangle. Number two, I kind of like because you can think of that as a bagel or a donut, and if you were to slice it down the middle, we again want to know what the inside would look like, what the flat thing inside would look like. So if you think about what that space is when you go to put cream cheese on your bagel, it kind of looks like that. So that's just going to be a circle with another circle inside of it. So if you described it that way, that would be fine. Technically, what it's called in math is it's called an annulus, is what we call that. Okay? And now let's look at the last one. So that's a cylinder. If we were to take that and we were to slice it, we want to know, if we took that, think of it as a piece of cake, and you were to slice just a section of it off, what the inside shape would look like. So if I really think about what that flat part would look like, it's going to end up looking like this. That's what's going to get stamped on there. But it looks like a parallelogram, but we need to think about if we looked at it straight on, what that would be. This one's going to be a rectangle. Okay? So hopefully that helped you to see visually what we're looking at there. There's some for you to practice on ClassKick, and there's also some for you to practice on the homework. So we're going to kind of stick with the same drill. We're going to do ClassKick and homework just to check in and see your understanding. And then we'll be doing some in-class assignments and a quiz later next week. All right, guys, get back in school mode. Hopefully I'll talk to you guys tomorrow morning. Hang in there. Bye.